Good morning, everybody. Welcome. We're so glad you're here to join us for Space Fest 2022. We'll get started in just a moment. We're going to let everyone come into our Zoom room and then we'll kick things off. We're so glad that you're here with us today on a very cold day in Minnesota, cold and dreary day in Minnesota, looking out the windows. Welcome, welcome, everyone. Glad you're here. I think we're going to have an exciting talk with our friend Staci Tiedeken today. Okay, well, I think I'm going to get us started here. I'm going to stop sharing my screen. Okay, let's kick this off. Good morning, everyone. We're so glad you could join us today for the Bell Museum's 4th annual Space Fest. My name is Holly Menninger, and I am the Director of Public Engagement and Science Learning here at the Bell, and I am delighted to be your host for today's virtual event. Our theme for Space Fest 2022 is the future of space exploration. As we look ahead to exciting space missions planned to explore the far reaches of the universe, I'd like to first ground ourselves here on Earth. We recognize that the colonial history of exploration on Earth has harmed Indigenous peoples and exploited natural resources, with legacy effects ongoing today, including here in Minnesota. I would like to specifically acknowledge the Dakota people, Indigenous keepers of the land on which the Bell Museum sits and from where I'm joining you today. This land is Dakota land. It was reserved by them in multiple treaties, and it remains sacred to them today. The Bell is a statewide institution, and so I would also like to acknowledge the Ojibwe people, traditional keepers of lands to the north. Dakota and Ojibwe knowledge systems are crucial ways of knowing this place now called Minnesota, and we at the Bell honor that knowledge, the values embedded in it, and the people who keep it. And so, with our feet firmly rooted here on Earth and our eyes gazing out towards the universe, I'm so excited to introduce our guest speaker today, Staci Tiedeken, who is the Outreach Coordinator for the Solar System Exploration Division at NASA's Goddard Space Flight Center. With Staci at the helm, we'll explore groundbreaking space missions to destinations throughout the solar system. In addition to her role as Outreach Coordinator for the Solar System Exploration Division, Staci is also the International Partnership Coordinator for International Observe the Moon Night, an annual worldwide event that celebrates the moon. She has a Bachelor's of Science in Astrophysics from the University of Minnesota, Twin Cities, go Gophers, and a Master's in Astronomy from the University of Iowa. Following Staci's talk, we'll have plenty of time for questions, so please use the Q&A box to ask your questions throughout the talk. You may have also noticed that we are live captioning our event today. If you find that distracting, you can hide it by clicking on the live transcript CC button at the bottom of your Zoom screen. And so, without further ado, please help me welcome Staci Tiedeken.
Hi, everyone. Thank you so much for tuning in to this discussion of planetary exploration, and on a Saturday, no less. I know it's quite cold in Minnesota, but it's pretty nice here in Maryland. But I'm truly excited to be speaking with you all today. And as Holly mentioned, my name is Staci Tiedeken, and I'm the Outreach Coordinator for the Planetary Science Division at NASA Goddard, which is in Maryland. And I'm also a University of Minnesota alumna, so go Gophers. And I'm especially honored to be speaking with you all today. Even though we couldn't meet in person this year, it's still great to be able to connect virtually to celebrate the Bell Museum's 150th anniversary. So with that, I'm going to share my screen. There we go, awesome. All right, so today we're going to be learning about some pretty cool space missions that will explore or that are already currently exploring a variety of places in the solar system. But I'm just going to focus on a few because there are a lot of them. And then you'll also have the opportunity to learn more about the Mars Perseverance rover and Artemis missions to the moon tomorrow with your regional NASA solar system ambassadors. But before we get too far into things, I thought I'd discuss a little bit more about my background. So as Holly mentioned, I went to the U of M Twin Cities for undergrad, where I received my BS in astrophysics. And then after undergrad, I went down to Iowa, the University of Iowa, for my master's degree in astronomy. And then after graduating with my master's, I knew that I wanted to do a little bit of traveling before starting my career. So I took a position as a summer space camp instructor at the Center of Science and Industry, which is in Ohio. And when this ended in August of 2017, I actually drove down to Nashville, Tennessee to watch the total solar eclipse, which was amazing. And if you haven't seen a total solar eclipse before, I would highly recommend it. There will be another opportunity for viewers in the US to see a total solar eclipse in April of 2024. So mark your calendars. It's going to be going from Texas to up to Maine. So I'd highly recommend going and seeing a total solar eclipse. So after my stint as a space camp instructor, I began a 3-month internship at an astronomical society called Astronomy Ireland, which was in Ireland. So with this organization, I helped organize observing nights and other public events. After my time in Ireland ended, I came back to the US and then began my job search. And that's when I found that NASA Goddard was actually hiring someone for public outreach. So I jumped at the opportunity, and that's how I ended up to where I'm at now. And then I always like to include this slide because it shows the wide range of things that I get to do for my job, with more focus towards virtual events, of course, over the past few years. So the image at the bottom right here is a screenshot from a program I started for senior living communities during the pandemic. And that's our speaker. This was from last July. He was talking about solar sails, and my co-organizer there is Florence Tan on the bottom. And this is an opportunity for senior citizens to tune in to listen to a NASA scientist or engineer talk about a really cool topic. And this slide also shows my favorite image, which is on the upper left. This was actually at the event at the Bell Museum in February of 2020, so just before the pandemic. And in it, I'm talking about the moon. But if you look at the man behind me, who has a great big smile on his face, that's actually my dad. And seeing how happy he is just makes me smile. And then a few of these other events showcase some of the wide range of things I'm able to do. So the one on the bottom there, that's actually at an event called Geek Girl Con, which is in Seattle. And this was a panel that talked about the different careers that are available at NASA. And then another really exciting event that happens every year, well, it tries to happen every year, is the one in the middle to the right. This was actually at Fenway Park. We partner with the Boston Red Sox for a STEM Day event with local students. So it's pretty fun. It's a pretty fun time. All right, so I'd like to start out our discussion showing this planetary fleet exploration. So this is a diagram showing NASA's current fleet of different planetary missions. So as you see, there are a lot. I'm only going to touch on a few, but it is really exciting to see how many missions there are out there right now. So the ones in blue are in their extended operations phase. So like Juno, it ended its primary mission, but now it's in an extended mission phase. The one in green are currently in their normal operating. So they're either just launched or they're still going out into the solar system to explore their destinations. And then the ones in yellow and orange are in the current implementation or formulation phase. So they'll be launching within the next few years. Okay, so I'm going to start out our discussion with the moon because it's one of my favorite objects in the sky. So we actually currently have a spacecraft called the Lunar Reconnaissance Orbiter, or LRO, that's actually orbiting the moon right now. And LRO was launched in June of 2009, and it's still collecting valuable data that's helping us prepare for the upcoming Artemis missions to the lunar South Pole. So it's been orbiting the moon for over 10 years and is still collecting wonderful data, which is pretty amazing. And this is one of the things that LRO has provided us. And this is actually a map of the lunar far side. Now the moon is not this colorful, but this is actually what we call a topographic map. So this shows differences in elevation on the lunar surface. So the blues and the purples are lower parts of the moon, while the reds and the whites are higher, more mountainous parts of the moon. And you'll notice this giant blue purple region in the southern far side of the moon. This is actually called the South Pole Aitken Basin, and it's the largest impact basin on the moon. Its diameter is about 2,500 kilometers, which means that it stretches over nearly a quarter of the moon. So this translates to roughly about the height of the contiguous United States. So it's a very big impact basin. And we also, a fun fact, we also know the topography of the moon better than we know that of the Earth, because the Earth has oceans. So the oceans are in the way. And LRO has also imaged each of the 6 Apollo landing sites. And I've shown the Apollo 12 landing site here because it's actually my favorite Apollo mission. And you can see the lunar lander's descent stage. It was called Intrepid on the surface here, right here. And then you can see the astronaut tracks that they took while they were out exploring the surface of the moon. You can see the equipment that they left behind. And then they actually went and visited the Surveyor 3 spacecraft that had landed on the moon a couple of years before Apollo 12. And they brought back pieces of that spacecraft so that they could analyze what, being in space does to equipment, which is kind of cool. LRO also has an instrument on board, which is called LEND, and its job is to look for water ice. So the mission has identified likely deposits of water ice in a handful of craters at the moon's south pole, including what we call permanently shadowed regions, which have gone without sunlight for millions or even billions of years. And also recently in 2020, NASA announced the discovery of water on the sunlit surface of the moon. And this discovery was made by SOFIA, which is an airborne observatory. And if you're interested in learning more about the history of water on the moon, moon.nasa.gov has a great article about this topic, which I believe we're putting in the chat here if you want to learn more, it's a really, really neat, fascinating history. And then a future lunar explorer is actually going to help us learn more about water on the moon. So in 2023, NASA's Volatiles Investigating Polar Exploration Rover, or VIPER, will land near the western edge of a crater called Nobile. And this is a crater that's at the moon's south pole. And it's going to map and explore the region's surface and subsurface for water and then other resources. And this is actually NASA's first mobile robotic mission to the moon. And it's part of NASA's Commercial Lunar Payload Services, or CLPS initiative, along with Artemis. Nobile crater is an impact crater that was formed through a collision with another smaller celestial body, and it's almost permanently covered in shadows, allowing ice to exist there. And there are some smaller, more accessible craters surrounding Nobile's perimeter, which will also provide VIPER with some ideal locations to investigate in its search for ice and other resources. That was a little bit about the moon. So we're now going to go from the moon and onto the planet Venus. So even though Venus is not the closest planet to the sun, it is still the hottest. And this is because it has a thick atmosphere full of carbon dioxide, which is a greenhouse gas. In comparison, we have the Earth here, and Earth is mostly made out of nitrogen and oxygen, as most of you know, which is nice and breathable. But because of its thick atmosphere, the pressures that you would experience at the surface of Venus would be like if you were 1,000 meters below the sea. So it's super crushing. Venus also has some corrosive sulfuric acid clouds, which would also not be very pleasant to experience. They're about 15 miles thick. And Venus is so hot that metals like lead would be puddles of melted liquid. And as a fun comparison, Restaurants bake pizza anywhere from 800 to 900 degrees Fahrenheit, while the average surface temperature of Venus is a balmy 864 degrees Fahrenheit. So it is indeed quite hot. Another neat thing about Venus is that it is the brightest planet in the sky, and it's currently visible in the early morning hours around sunrise. So this is a lovely image of the crescent moon next to Venus on the left there. So you can see Venus either, depending on where it's at in its orbit, you can see it near sunrise or near sunset. So if you get up early enough right now, you can see Venus in the early morning hours. So despite its differences, Venus is sometimes referred to as Earth's sister planet because it is similar in size and density. So Venus may have actually been far more Earth-like than its present climate state. So it may have had liquid water on its surface, but something happened in its distant past that made it the inhospitable world that it is today. And this is an especially exciting time to be a Venus fan, since NASA is sending 2 missions to the planet, Da Vinci and Veritas. These missions will provide a new window on the evolution of planets in our solar system and beyond. And Venus could also serve as a model for many exoplanets soon to be discovered in the era of new space telescopes, such as the James Webb Space Telescope. So it has been nearly 30 years since NASA has been to Venus. So the Magellan spacecraft last visited in 1994, and it was the first spacecraft to image nearly the entire surface of Venus. So it is definitely time to return to this mysterious planet. So one of the missions that I mentioned, the Da Vinci mission, was selected along with Veritas in June of last year as NASA's next discovery missions. And these missions are complementary and they represent a new era of Venus exploration. So Da Vinci is Goddard led, and it's named after the visionary Renaissance artist and scientist Leonardo da Vinci. And it will send a 1 meter diameter titanium probe, which is shown in this image here, to brave the high temperatures and pressures of Venus. And it's going to explore the atmosphere of Venus from above the clouds to near the surface. And during its final kilometers of freefall descent, the probe will capture spectacular images and chemistry measurements of the deepest atmosphere of Venus for the very first time. Da Vinci is going to help us answer such questions as how did Venus form and evolve from a past habitable state to its present one, and whether Venus used to have an ancient ocean. So while Da Vinci is mainly focused on studying the Venusian atmosphere, the Veritas mission will focus on studying the surface of Venus to determine its geologic history and understand why it developed so differently than the Earth. So Veritas is an orbiter that's coming out of JPL, which is in California, and it's designed to address a variety of questions, including what the major geologic terrains on Venus are made out of, what the major tectonic processes are that shape its surface, and whether or not Venus has active volcanoes. So the results from both Da Vinci and Veritas have the potential to reshape our understanding of terrestrial planet formation in our solar system and beyond. And these missions are expected to launch in the 2027 to 2029 timeframe. So get excited. Right, moving from Venus onto Mars, I wanted to touch on one mission that's been going strong since landing on the red planet in 2012, and that is the Curiosity rover. So Curiosity landed in Gale Crater in August of 2012. So it's actually going to be celebrating its 10th anniversary later this year. And it's been exploring and drilling samples ever since. And inside of Curiosity, inside the belly of Curiosity is an instrument suite called the Sample Analysis at Mars, or SAM for short. And SAM analyzes rocks by using an oven to heat up the samples in excess of 900 degrees Fahrenheit, so similar to the surface of Venus, to release molecules from the powdered rocks. And what Sam has found so far is that Gale Crater used to actually be an ancient lake bed. So it used to be a lake used to fill that location. And drill samples from this lake bed show key elements, organic molecules, nutrients, and energy sources that potential microbes could have used. And note that although Curiosity has indeed found organic material in the Martian soil, and that organic molecules are commonly associated with life, they can also be created by non-biological processes, and so aren't necessarily indicators of life, but they are super intriguing. And this is just a fun picture showing Curiosity with a hole that it drilled to sample some rock in front of it, and then it later climbed up to where that square box is up on the top. So it's been climbing up Gale Crater and the little mountain in the center of Gale Crater for the past 10 years now. And these are some of the drill holes that Curiosity has created. So the rover pulverizes rock samples with the drill on its robotic arm, and then it sprinkles the powder inside where a pair of instruments determines what chemicals and minerals are present. And the different colored drill holes here, shown here, represent the different variations in the soil's chemical composition. It's a pretty nice composite though. And this is just another fun selfie of Curiosity exploring Mars. There are a lot of Curiosity rover selfies or rover selfies in general on Mars. And I always find them so fascinating because there's another, there's a rover exploring another planet. And just to see the differences in the surface compared to the Earth is pretty fascinating. So we're now going to move on to the exploration of Jupiter. So Jupiter is the largest planet in the solar system. It's actually wide enough to fit 11 Earths across its diameter. So it is very big. It also has a very distinct great red spot, which is shown in this image. This is a giant storm, a bit larger than the Earth, that has been raging for centuries. And just to get a sense of how big this storm is, here's a comparison of the Great Red Spot and a Category 5 hurricane on Earth. So that little white dot that says actual size of storm, that is the actual size of the Earth hurricane. So compared to the Great Red Spot, it's very dinky. And here are some numbers just to further compare the two storms. So as you can see, the Great Red Spot is indeed very big. So we currently have a spacecraft that is in orbit around Jupiter. It's called Juno, and it arrived on the planet on July 4th, so good Independence Day of 2016. And Juno has discovered some pretty interesting features, including swirling continent-sized storms densely clustered at both poles. And this image shows the central cyclone at Jupiter's north pole, and then you can see the 8 cyclones that encircle it. And this is not a visible light image, it's actually what we call an infrared light image. So the colors represent heat. So the yellow are thinner clouds, and they're about 9 degrees Fahrenheit in temperature. And then the dark red clouds are thicker clouds, and they're a balmy negative 181 degrees Fahrenheit. So because Jupiter is far from the sun, these clouds are still quite cold. And findings from Juno have also provided a fuller picture of how the planet's distinctive and colorful atmospheric features offer clues about the unseen processes below its clouds. So the Jupiter's banded appearance is actually created by what we call the cloud-forming weather layer. So this is a composite image that shows Jupiter in infrared light at the left, which was taken by the Gemini North telescope, and then Jupiter in visible light at the right, which was taken by Hubble. So science results from Juno show that Jupiter's cyclones are actually warmer on top with the lower atmospheric densities, while they're colder at the bottom with higher densities. And then anticyclones, which rotate in the opposite direction, are colder on the top, but warmer at the bottom. So Juno continues to study and collect data, sending back some pretty spectacular images. And the visible light camera on board Juno is called JunoCam, and it's actually a really cool citizen science project where members of the public are able to process all the images that JunoCam takes. So I included this specific slide because if you go to this website, you will be amazed with some of the really cool images that people have processed from JunoCam. And I'm going to show you some of them now. So these are some of the pretty incredible images that the camera has taken since arriving at Jupiter. So Jupiter has a lot of chaotic and turbulent regions that produce these kind of swirling cloud formations. So in general, the darker cloud material is deeper inside of Jupiter's atmosphere, while the bright cloud material is higher. And the bright clouds are most likely made out of ammonia, or a mixture of ammonia and water, mixed with a sprinkling of unknown chemical ingredients. And this is a nice image showing the famous Great Red Spot. This is a neat perspective. It's showing the Great Red Spot in the northern hemisphere because Juno is approaching from the south. And this image is from Juno's 16th close flyby of Jupiter. We're actually now on the 39th close flyby, but it shows a dolphin swimming through the Jovian seas, which is kind of cool. And then this image shows two of Jupiter's large rotating storms that was captured pretty recently on November of 29th of last year. And you'll notice these bright pop-up clouds here that are visible above this lower storm that are casting shadows on the cloud bank below. So although they look very small in comparison to the large storm below, such clouds are typically about 30 miles or 50 kilometers across. So they're still pretty big clouds. So Juno's prime mission actually ended in July of last year, but its mission was extended through September of 2025. So it will be able to continue its investigation of Jupiter for a while yet. And in its extended mission phase, Juno will become an explorer of the full Jovian system. So Jupiter, its rings, and its moons, with multiple rendezvous planned for 3 of Jupiter's Galilean moons. So Ganymede, Europa, and Io. So that'll be exciting. And we're now going to next move on to Saturn's exotic moon, Titan. So before completing its 13-year tour of the Saturn system in September of 2017, the Cassini spacecraft made a variety of surprising discoveries about Titan. And one of these comes from Cassini's radar images, and one of which is shown in this image here. And this revealed that Titan has many lakes and seas, some of which are filled with liquid and some of which appear as empty depressions. And some of these lakes are actually several hundred miles across and up to several hundred feet deep. And Titan is actually the only world in our solar system other than the Earth that has stable liquid on its surface. However, the liquid in Titan's lakes and seas is mostly made out of methane and ethane. So we tend to think of these hydrocarbons as a gas on Earth unless they've been pressurized in a tank. But Titan is so cold, roughly -300 degrees Fahrenheit, that they behave as liquids, like gasoline at room temperature on our planet. I guess Cassini also delivered a descent probe from the European Space Agency called Huygens to Titan's surface in 2005. The probe's descent lasted about 2.5 hours, and it survived another 72 minutes on Titan's surface. And this was the first and so far the only landing in the outer solar system. But don't worry, we're working on returning to Titan with the Dragonfly mission, which I'll talk about in a little bit. And then the images at the the image at the left shows what Huygens might have looked like on the surface of Titan. This is an artist representation. And then the images at the right show a pretty cool side-by-side comparison of Titan's surface with a similarly scaled picture taken on the moon's surface. So objects near the center of the image are roughly the size of a human boot print. I briefly mentioned the Dragonfly mission. So I'd like to go back to this exciting mission now. One of the distinct features of Titan is its thick nitrogen atmosphere. It also has low gravity, and the Dragonfly mission will take advantage of both of these aspects. The Dragonfly is a rover-sized, drone-like vehicle and is shown in this illustration on the surface of Titan. The rotorcraft will explore dozens of different locations across the icy world, sampling and measuring the compositions of Titan's surface materials to search for the building blocks of life. The Dragonfly is scheduled to launch in 2027 and will arrive at Titan in 2034. So the image at the left here shows a Dragonfly mission concept of you have entry with the parachute, landing, surface operations, and then flight at Titan. The Dragonfly will make multiple flights and will explore a variety of different locations on Titan. And the dense column atmosphere and low gravity make flying an ideal way to travel to different areas of the moon. So studies from the late 1990s onwards identified aerial mobility, such as that provided by helicopters, balloons, and airplanes as a key enabler for Titan exploration. So in under an hour, Dragonfly will cover tens of miles or kilometers farther than any planetary rover has traveled thus far. With one hop per full Titan day, and one full Titan day is actually 16 Earth days, Dragonfly will be able to travel from its initial landing site to cover area several hundred kilometers away. But despite its unique ability to fly, Dragonfly will actually spend most of its time on Titan's surface making science measurements. So we're now going to move on from Titan to explore some asteroids. And one mission in particular is called the OsirisRex spacecraft, and it arrived at the near-Earth asteroid Bennu in December of 2018. So Bennu is the smallest object, it's about 510 meters, or a little bit taller than the Empire State Building, ever to be orbited by a spacecraft. And OsirisRex also broke the world record for the closest orbit of a planetary body, with its orbit 0.4 miles above the surface of Bennu. And for comparison, the International Space Station orbits the Earth about 250 miles above the surface. So it was very, very, very close to the asteroid. And the mission is NASA's first asteroid sample return mission, with OsirisRex successfully collecting a sample of Bennu on October 20th, 2020. It's actually currently on its way back to the Earth and will land in the Utah desert in September of 2023 with the precious sample. And studying the sample will provide some information about the early history of the solar system and will help scientists develop future missions to mitigate asteroid impacts at Earth. So this image shows boulder formations on Bennu's surface, and its surface features are actually named after mythological birds and bird-like creatures. And this is complementing the mission's existing naming theme, which is rooted in Egyptian mythology. So ancient Egyptians usually depicted Bennu as a gray heron. And there was a 9-year-old boy, I think he was from North Carolina, that won the Name That Asteroid competition. And he thought that the OsirisRex spacecraft looked like a bird, so he wanted to name Bennu in honor of that representation. And one of the first findings that OsirisRex revealed was the indication of ancient water locked inside the clays that Bennu is made out of. So this means that at some point, Bennu's rocky material interacted with water. So while Bennu itself is a little bit too small to have ever hosted liquid water, the finding indicates that liquid water was present at some time on Bennu's parent body, which was a much larger asteroid. And then I wanted to show this series of images because it shows what the sampling event called TAG actually looked like. So this is OsirisRex's sampling arm impacting Bennu's surface to collect a sample. So the goal was to collect at least 60 grams of material, which is about the mass of a tennis ball. But the spacecraft actually ended up collecting too much material. It ended up being an overachiever. So this series of images shows particles floating out of the collection chamber after the tag event. So the collection lid wasn't able to close properly because pieces of rock had kept it wedged open. But everything ended up being okay because we were able to properly stow the collected sample inside the sample return capsule, which is shown in these two images. And then this animation shows how Bennu's surface was changed during tag. So the red X is where OsirisRex impacted the surface. And you'll notice that the rocks and dust were moved as a result of the sampling event. So it's kind of cool that we were able to look back at the sampling site and see how the surface was changed. And a few months after successfully collecting and stowing the pristine sample, OsirisRex said goodbye to Bennu and is now on its way back to Earth. So this was OsirisRex's farewell departing image of the asteroid that it had spent visiting for a couple of years. Let's now talk about the Lucy mission to the Jupiter Trojan asteroids. So Lucy launched quite recently on October 16th of last year, and it's going to be the first to visit the Jupiter Trojans, which are two populations of primitive asteroids orbiting in tandem with Jupiter. So these are remnants of planetesimals, which are the primitive building blocks that formed the planets. And the Jupiter Trojans were captured in two regions, shown in this diagram, near points where the gravitational influence of Jupiter and the sun balance. And this screen grab was actually taken from a Lucy cartoon series that you can find if you just search Lucy mission cartoon series. It's a really fun series. I think there's 8 episodes. It goes through Lucy's mission from launch to, Lucy actually exploring the Jupiter Trojan. So it's quite good. It's about maybe 10 minutes total, I think. But the name of the mission actually itself has an interesting story. It's named after the fossilized skeleton of an ancient ancestor of modern humans. And this is fitting since Jupiter Trojans have remained trapped in their orbits, mostly untouched, for billions of years. And they are like fossils of planet formation. So by studying these fossils of planet formation, the Lucy mission could reveal as much about the development of the solar system as the Lucy fossil did about human evolution. So Lucy will complete a very long journey. Its mission is actually 12 years to 8 different asteroids, which are shown here. There's a main belt asteroid and then 7 Trojans, 4 of which are members of what we call the 2 for the price of 1 binary systems. And this image here shows 2 engineers working on LaRalph, which is one of the instruments that's on the spacecraft. LaRalph was the 3rd and final instrument, scientific instrument, to be integrated onto the spacecraft in January of last year. So LaRalph was built by NASA Goddard and is the most complicated instrument aboard Lucy because it's actually 2 instruments in one. So we have the multispectral visible imaging camera, which will take visible light color images of the Trojan asteroids, while the linear eidolon imaging spectral array, or LISA, will collect infrared spectra of the asteroids. So both of these components will work together to allow Lucy to determine the different compositions of the Trojan asteroids and provide insight into the early history of our solar system. So the first spacecraft to leave the solar system carried with them messages from Earth for any intelligent life that may one day encounter them. The Lucy mission continues this tradition, but the plaque it carries as a time capsule, which is shown here, is not for unknown aliens, but it's actually for our own descendants. So after the Lucy spacecraft completes its mission, it's going to remain on a stable orbit, traveling between Earth and the Trojan asteroids for hundreds of thousands, if not millions of years. So we're with the thought that, maybe our descendants might one day go and retrieve the spacecraft, the Lucy team chose to put a time capsule aboard Lucy in the form of this special plaque, which includes messages from prominent thinkers of our time, as well as this diagram showing the different what the different planetary orbits were on the day of launch in October of last year. Because Lucy is so long, one of our public engagement activities is to ask you to follow along with Lucy on the spacecraft's 12-year journey by building your very own Lucy time capsule. So what objects, sounds, ideas, or words will serve as memories for you and your family to look back upon as Lucy carries out its mission into the next decade? And you can revisit your Lucy time capsule and continue to add to it throughout the mission as various milestones happen. So the image at the right here is an example of one of the Lucy team members' time capsule. So she really liked the pineapple socks and, of course, the face mask, which is very popular. And because I wouldn't be doing my job if I didn't give a plug for future outreach opportunities, here are a couple of upcoming public engagement events. So this April, we will be celebrating the 50th anniversary of Apollo 16, and we'll be celebrating the 50th anniversary of the final Apollo mission, Apollo 17, in December of this year. And International Observe the Moon Night was mentioned at the very beginning. So I'm the International Partnership Coordinator for this event, and it's a worldwide celebration of lunar science and exploration, celestial observation, and our cultural and personal connections to the moon. So every autumn, we invite everyone on Earth to observe, learn about, and celebrate our moon together. And the images shown here are from events held last year all around the world. So you can see just how international this event is. You know, places from Honduras, Australia. We have researchers observing in Antarctica that also participate. And if you participate, you can pop up on our map and it will show the different observers all around the world who are observing the moon together, which is really cool. So mark your calendars for this year's event. It's going to be on Saturday, October 1st. And there's a link to our website as well, moon.nasa.gov/observe. And with that, I will wrap up and say thank you very much for tuning into this presentation. Obviously, I couldn't include all the missions that we're involved in, but I hope this provided a pretty good snapshot. And then I also wanted to leave this page of resources up since there are a lot of great planetary content. There's a lot of great planetary content out there. And in particular, these resource packages that are linked at the bottom provide some at-home activities that you can do with different age levels, along with videos and animations, and then stories of whatever topic you're searching for. So I will now take any questions that you all might have.
Thank you, Staci. Very exciting. What a fantastic presentation. So audience members, please use the Q&A box to type in your questions so we can make sure that we get those for Staci. I don't know, Staci, if you still want to share your screen or if you wanted to, it may make sense later to go back and forth with some stuff. While we're waiting for audience questions to come in, so again, please use the Q&A box. I'm going to take my host privileges and ask some questions of my own while those are coming in. So my first question, Staci, is how does NASA decide which planetary missions to take? And like how much lead time? Because you started your talk today with a really big, with a overview of all of the missions, sort of ongoing, planned. Tell us a little bit more about that planning and decision process.
Yes, so a huge part of this has to do with what the NASA budget will be for, that fiscal year, the following years. So that takes in, that's a big part, because of course we would like to do all of the missions, all of the proposed missions. But so I mentioned the two Venus missions that were selected. There were actually 4 that were down to the final 4, but we could only pick 2. So that was what we call it was part of the Discovery class of missions. There's also the New Frontiers class of missions. So depending on which class you're proposing, there's a different budget range for those missions, and some are very big. You get James Webb, which is a huge feat of both engineering and planning, and then you get smaller missions that don't cost as much money, so you can select more of them. But so Da Vinci was actually proposed, I think, 4 times and not selected until last year. So it takes a lot of time and effort on behalf of all of these science teams that are proposing these missions. So from planning stages to actual launch can take like years, like many years, like 10 years. So it does take a long time. And yeah, it's pretty incredible just seeing so at Goddard we have the mission concept, from mission concept through to mission completion. So you can go to Goddard and see like the mission operations room. You can see people actually testing in the clean room and the vibration. So all aspects of mission development there. And did I answer all of your questions?
I think so. That was great. That was great. Yeah. Okay. All right. Audience questions are like coming in fast and furious. Maybe if you'll stop sharing your screen now too, so that we can see a little bit better. And this kind of relates to one of the questions I think that Jefferson had. You've mentioned a couple of missions, both to the moon and then to Bennu, where NASA's looking for water. Why is NASA so focused on the search for water?
That is a great question. So water is a resource. So for the moon in particular, we're planning on going back to the moon with the Artemis missions and landing in particular at the moon's south pole, because we know water is there. And water can be used as both drinking. So you have to figure out first how to purify it so you can actually drink the water, make it safe. But it can also be used as a resource for fuel, because water is hydrogen and oxygen. So we can, break those apart and make fuel, and then go on from, if you make your own fuel on the moon, it's a lot cheaper to go onto Mars from the surface of the moon rather than the Earth, because it doesn't take as much oomph to get off the surface. So those are the 2 main reasons why we're so interested in water.
And are there other plans? I guess this is really Jefferson's question. Are there any plans in the works to actually start making that fuel on the moon? Have those been developed yet?
I know that it's being researched, the different techniques, but it's hard because testing this on the Earth is not going to be the same as doing it on the moon, right? Because the moon has different gravity, it has different environment. So yes, we are focused on these techniques because we are planning on setting up an Artemis base on the moon. So we will need to figure this out. Yeah, that's a good question.
Mona asked a great question. How fast are these satellites traveling if it takes many years to reach their target destination?
That is a good question. So I don't know off the top of my head, but you have to go, like the International Space Station is traveling at 17,500 miles per hour to not, keep in orbit around the Earth. And I think Pluto, the mission New Horizons to Pluto was the fastest, but that was because it just went straight, like it just went. But I don't know the mileage off the top of my head. But it does, we're limited by the technology, the technology that we have. So yeah, it takes 3 days to get to the moon if you have humans aboard. If you don't have humans, you can go a little faster, but that's a good question.
Yeah, that's great. Rajan asked a similar question I had. I didn't realize Curiosity has been working hard for the last 10 years, and probably feels a little sad that they're out of the spotlight, because Perseverance has dominated the news cycle, Perseverance and Ingenuity, the helicopter. Rajan asked if you wouldn't mind giving us a little bit of an update about what's happening with Perseverance and
so I didn't mention those. They are really cool, but yeah, I wanted to make sure that the solar system ambassadors tomorrow would be able to chat about them.
Nice. Well done.
But yes, I know. But so Perseverance is, if you're not aware, it actually landed on Mars on February 18th of last year. So it's almost been on the surface for a year this month, which is really exciting. It's going to, or is, drilling samples just like Curiosity is, but it's actually caching these samples. So not all of them, but it's gonna, if it identifies a particularly interesting sample that we want to study on the Earth, it's preserving them in these sample tubes so that they can be collected by future missions, in particular the Mars Sample Return mission. So that is a big part of Perseverance's job, is to preserve some of these samples for future analysis on the Earth, which will take a while, but it's pretty cool. And Ingenuity is actually it's also very cool. That one and Dragonfly, I'm like, ooh, flights on other planets. So that is actually conducted the first powered flight on another planet. So it's a helicopter. It's successfully completed its 30-day initial mission and is now actually scouting. It's practicing to, if we do land humans on Mars, it's practicing on how, if you rather than humans walking to a particular destination and being like, oh, this isn't great, this isn't a good spot to go, we should have gone this other direction. Ingenuity is what we call scouting out different locations by flying, and then can come back to its spot and report back, and if there were humans on the Earth or on the planet. So yeah, they are very cool missions.
Yeah, and just as a plug for our audience, we will have 3 NASA Solar System ambassadors talking about the Artemis mission, as well as Mars Perseverance and Ingenuity tomorrow at 11. So please tune in then. Someone in our audience asked the question, I also shared this question: how does NASA choose the name of spacecrafts and missions? They seem incredibly creative, also incredibly creative use of acronyms. And tell us about how those are decided and figured out. Who's in the room where that happens?
Yes, so that is the PI of the mission, the principal investigator. So OsirisRex, I'm not even going to remember what that stands for. It's a bunch of origin spectral interpretation of regolith explorer or something. So that one in particular is a description of what the actual spacecraft is doing. And it's OsirisRex because it sounds kind of cool, catchy. But yeah, most of the acronyms will stand for something, and you're in a room with a bunch of scientists, so they're going to try to figure out a really fun acronym. Like the Lunar Reconnaissance Orbiter LRO, that was just it's reconnaissancing the Earth and the Moon. So but a lot, and some of them actually, like Curiosity and Perseverance and the Mars rovers, were named by students. So these were challenges that were sent out to people around the country, and NASA selected whatever, like Perseverance, because it was a persevering through times and that sort of thing. So the schools, also students, have the opportunity to name some of these missions. So I think it's a mix of different.
Are there any missions coming up in need of a name so that our audience can be on the lookout, or is that top secret information? We got to wait till we got to follow NASA on social media, and we'll figure out those.
I should. Yeah, I am not aware of any unnamed missions. Usually by the time I hear of them, they have been named. But Da Vinci, actually, it used to be Da Vinci Plus, but they took off the plus because it was, it was like the new proposed mission, so they wanted it to call it Da Vinci Plus. But now it's just Da Vinci because it's easier to say.
Okay, there we have it. All right, Stern asks a question: if Venus is so hot, does it not melt anything that is put on the surface?
Right. So that is another engineering challenge. I mentioned Da Vinci. Da Vinci is a descent probe. It's about 1 meter diameter. It will be 1 meter diameter. It's made out of titanium. So the main goal of Da Vinci is actually an atmospheric probe. So it's going to be sampling different layers of Venus's atmosphere as it descends through the atmosphere to land on the surface. It's not actually going to be a surface operations mission, so it doesn't actually necessarily need to survive. If it does survive, that's bonus points, but the mission isn't proposed saying that it's going to go and do some surface operations. But if it does, that would be extra brownie points because it is challenging. But the main part of the mission is to study the atmosphere.
Gotcha. You mentioned that like Venus had kind of been ignored for a real long time. Now there are 2 missions. I think Venus must be Chris's favorite planet. Because Chris wants to know if there are any additional Venus missions or mission concepts in the works.
Yes. So in addition to the 2 that NASA selected, ESA, the European Space Agency, is actually also sending a mission to Venus. I think it's called Envision. So another fun name. So that's going to be, these 3 are going to launch in like a similar period of time, and we'll be able to provide a lot of really fascinating discoveries for the next decade, because it's going to takes a while for these missions to go from implement or a concept stage to selection to design to actually built and then sent to Venus. So there is another one at ESA, but yeah, there's Venus is going to get some love, so that's exciting.
There you go. I think people have very diverse interests in terms of their favorite planets, because someone else asked, are there any plans to send missions to Uranus or Neptune?
I would love to send a mission to the ice giants. Yes. So there aren't. There are people that are planning, like Trident is actually a mission to Neptune. It was one of the 4 discovery missions that were down selected, but then it wasn't picked. So the 2 Venus missions were. But it's harder to send spacecraft to the outer planets because they are so far away, and we're limited by, if we send a mission out that far, it could take many years to get there. So the orbits of all the planets have to align properly to actually, send spacecraft out until we get better technology. But I would like to send a spacecraft to the ice giants, because we don't have much knowledge or data from these planets. So I'm with you with the why can't we send them to the outer planets?
Gotcha. Steve wants to know, of all that's been discovered in the missions you reviewed, what is the most fascinating discovery or detail to you? So your personal favorite of all the things you've talked about.
Well, I didn't really talk about, I kind of touched on Titan a little bit, but I think the amount of ocean worlds that are possibly out there is what I think is like the coolest. So I mentioned Titan. Titan, we think, has a global water ocean underneath its surface. And then you have Europa, another moon of Jupiter that is also considered an ocean world. You have Enceladus, which is a moon of Saturn. So the discovery of these ocean worlds, I think, I don't know if I have, it's one of my favorite things, because there's just so much potential with that. So yeah, ocean worlds.
That's awesome. I really appreciated, Staci, how you shared a little bit about your education and career journey at the start of your talk. What advice would you give young people in our audience who are interested in space science and astronomy?
That is a good question. I don't know, I recommend you will, if you expect that you will encounter difficulties in your journey to explore, sciences, you won't be as surprised by these difficulties, but I think the main thing is to just persevere. You will encounter, tough classes if you want to pursue some astronomy, physics, chemistry, geology classes. But I would just recommend keeping at it. There's different angles you can take to attack a problem. There's always help. I spent many hours in office hours, so there's no shame in not knowing how to do something. You just ask and keep at it. So, yeah.
That sounds great. Hey, I got to ask before we close. I noticed that the members of the Beatles and or their loved ones had quotes on the Lucy plaque. You want to talk about that?
Yeah. So I think one of them, Ringo, maybe. I think he recorded a video for the spacecraft or for the launch. I wasn't part of the let's go and get all of these people, but yeah, I think one of the PI or the co-PI were the big Beatles fans. So they were one group, and they had some influential poets that also provided some quotes and stories, and yeah, but it's kind of fun. You can search. They provided a video too. So
yeah, I think that'll make Lucy in the Sky with Diamonds have a little bit more meaning to folks out there. The younger kids in the audience who might not know what we're talking about, you might want to.
Well, that's why we have a Lucy cartoon series that you can check out. So yeah, it's a very fun. It's cute, and yeah, it's adorable.
Awesome. Awesome. Well, thank you to our audience for asking so many good questions today. And thank you to Staci. We are just so thrilled to have you here. So, and for being our special guest today. So thank you for joining us. Now I'm going to do one more thing. I'm going to share my screen and let folks know that we have one more day left of Space Fest 2022. So tomorrow at 11 a.m., we'll have 3 NASA Solar System ambassadors leading us on a tour of upcoming missions to the Moon and Mars, complete with a hands-on activity. So make sure you sign up. The event is free, but you have to register to receive the Zoom link. And you can do that by going to z.umn.edu/space-fest-2022. We'll also be sharing recordings of today and tomorrow's events on the Bell Museum's YouTube channel. Finally, I would like, let me go, I'm trying to do all the things at one time. Here, next slide, there we go. I'd also like to note, and I think Staci mentioned this at the top of our time together, that the events of Space Fest 2022 are part of the Bell Museum's 150th anniversary celebration. Thank you to our 150th anniversary sponsors, especially our presenting sponsor, General Mills, for making this a truly exciting year for the Bell Museum. We also want to thank Ruth and John Huss for their continued support of the Bell's Minnesota's astronomy classroom programming. So with that, thank you, Staci. Thank you to our audience. Thanks everybody out there. Take care and have a great Saturday.
Thank you, everyone. Happy Saturday.